Welcome to Azure Blockchain Desperados. I'm Julia Nathan, a cloud solution architect at Microsoft.
And I'm Bob Jacobs. I'm also a cloud solution architect at Microsoft.
So today's topic, secure and reliable client communication with Azure KeyVault and Azure Kubernetes services, our second video on the topic, but today focusing on AKS. So today we'll cover a code sample for running Quorum microservices on Azure Kubernetes service. All the blockchain transactions are going to be signed using keys stored in Azure Key Vault, and all the Kubernetes pods are going to access Azure Key Vault by using a managed service identity using AAD pod identity. So Bob, why is this important?
Well, it's important for two reasons. One, we're just getting a lot of questions from customers on how to do this, and why it's important to them is what they're looking to do is to take advantage of existing AKS infrastructure to host microservice code so that they have one place that's interacting with the blockchain ledger and Kubernetes.
Okay. So definitely a relevant topic. And before we start moving into the code and demo, let's talk a little bit about the prerequisites that are needed for today's topic. So Bob, if you go ahead and pull up our repo, you can see a lot of this is documented right there. So we assume that you've already got Azure Blockchain Service stood up, you've already got an AKS cluster, and the other thing you're going to need is to have that configured with AAD pod identity. So I hear this can be confusing. Bob, what do you think?
Uh, it can be slightly confusing. I get a number of questions from customers. So let's just talk about how all the pieces are put together. So as Julia mentioned, there are some prerequisite knowledge around blockchain. There's prerequisite knowledge around Azure Key Vault as well as Ethereum. So all of the code that we're going to be presenting is written in .NET using the Ethereum packages. Most of the questions that I get are around AAD pod identity, and in the repository that's attached to this video, there is going to be a call out to the AAD pod identity repo on GitHub. So if we take a look at that, that's going to give us some instructions on how to get things wired together. And it's not all that difficult. Really what you're going to start with is we're assuming that you have a running AKS cluster that is up and running and in good standing. Once that's up and running, you're just going to execute a single command line. And what that command line is going to do is it's going to deploy a couple of resources into the Kubernetes cluster itself. One of those resources is the managed identity controller, and that has a few pods that are going to get deployed there. And the other is the node managed identity, which is a daemon set. And these resources are going to do all the heavy lifting that is going to allow your pod to get an AAD token using managed service identity and all of the things that managed service identity gives you. This is going to do all the heavy lifting for interfacing with that. We also need a managed service identity because that's what Kubernetes is going to look to take advantage of. So to do that, there's a well-known command line using the Azure CLI that you can find in the repo. So once we execute this command, we're going to have a managed service identity in our Azure subscription that we're going to use. So we have the resources that the pod needs. We have the resources that our administrators in Azure are going to need and that our code's going to need. Now we need to wire these together. So there's two additional resources in Kubernetes that we need. One is the Azure Identity resource, and then the other is the AAD binding resource. So I'm actually going to go to my GitHub repository that contains these resources that are pre-filled out. I just think it's a little bit easier to walk through. So the first is the AAD pod identity, or the Azure Identity resource. And this Azure Identity resource is really acting as an alias to the managed service identity that we created with the Azure CLI command in step 2. So you'll see that we name this pod ID. We're able to see this in action here because if I go to my resource group that contains my Kubernetes cluster, we'll see that we have this managed identity resource that's been created. On top of that, when we go to our Key Vault, we have created an access policy for this managed service identity, and we've given it the permissions that it's going to need to retrieve the key that lives in Azure Key Vault that is going to be used for signing all of our cryptographic transactions. Okay, so now that we have that alias set up and is pointing to that resource in Azure, we need one additional piece of information that we need to feed Kubernetes, and that is the Azure Identity Binding. So what the Azure Identity Binding is going to do is we're going to say, hey, for this alias, we need a selector. We want certain pods to say we want to use this Azure Identity Binding. So this selector is any arbitrary value that we want to give it. I gave it the name of food safety. And this can be referenced in our Azure Kubernetes deployments. So we have one in our repository called the quorumservice.yaml file, which is going to deploy our code. So basically, we've gone ahead and we've compiled this code and we've built it using a Docker file. We've taken that container image and we've pushed it into Azure Container Registry. And now we're taking this label called AAD Pod ID Binding, which is a well-known label, and we're giving it that value.
So any pods you have labeled with this value are actually going to use that mechanism that you've already showed, configured within Azure. They're able to use that managed service identity that's already configured with all of the access permissions that are needed. So it's just a really nice way to automate that process on behalf of your developers. Is that
exactly
it?
Right. That's spot on. That's exactly it. And if we want to see how this is wired together, we have a pre-deployed solution. This quorum service YAML file was pre-deployed, called quorum service. What you'll see is that we have an external IP address that we have access to, and we'll be able to execute REST transactions, and I'll show you what that looks like in a second. I did want to add one other key piece of information here I wanted to walk you through. Is in the code itself. Now that we have managed service identity wired together, as Julia mentioned, the code is super simple. We're really just giving it a KeyVault URI, and managed service identity just does its thing. The other value that this microservice is going to have is that we are taking any pre-compiled smart contract and we're putting it in blob storage. So if you go through the README, there'll be instructions on how to do that. We actually have a pre-compiled smart contract for the simple storage smart contract. It's well known for any blockchain development that you've done. Just simply does a get and set of a value. But we've pre-compiled this, we've stuck it into blob storage, and the code is going to retrieve this prior to making calls to the smart contracts. So anything that can be compiled can be reused. So now that this has been deployed, as a developer, I can simply make calls using simple JSON. So to create a contract, all we're giving it is basically some blank JSON data. What we get back is a contract address. So if we take this address and we want to post a transaction, in this case we're calling the set function with that contract address with a value of 60, we get all the information back that we would need, such as the block number and transaction hash. Then if we want to do a read-only function call, given that contract address and the function name get, we get the value back that we set. So everything working without credentials. Yeah.
That's amazing. Just using all of the mechanisms that you've demonstrated today. Pretty cool, Bob.
Pretty good. Yep.
All right. So I hope everyone enjoyed our demo today on the use of Azure KeyVault with an AKS cluster. Any final thoughts, Bob?
No, none for me. Just take a look at the repo that we have attached and experiment and get familiar with how all this stuff works.
Wonderful. All right, everybody. Thank you.
Thank you.